like the stream is running. Hi everyone, I am TigerHawkT3, and today we're going to make a simple little program in Python, only this time I'm going to deliberately include some common beginner mistakes, which is different from what I usually do, which is accidentally including uncommon beginner mistakes, like trying to use the modulus operation and having the operands backwards. That's bad. So we're going to do a number guessing game. There's a secret number. You have to input a number as a guess, and it will tell you whether it's too low or too high. If you guess the right number, the game ends. That's it. So we're going to do that. All right. Print, and we want input number, and remember I said mistakes on purpose that we will fix. While input is not equal to let's say 3. How about if input is less than 3, we will do, it's hard making mistakes on purpose. If input is less than 3, print too low. If input more than 3, print too high. Else, print yes. How about correct? Okay. I'm just gonna go ahead and run this. Number guess. And I'm gonna turn that on, and I'm gonna say pi number guess.py, and of course there is invalid syntax. And this line doesn't have any apparent problems with it, does it? This is this particular issue is the cause of much frustration, because there's not any syntax error with the line it's showing. The problem, of course, you've probably seen if you're interested in my stream and have watched it before, is that we are missing a parenthesis. I had actually added it initially, and then I was like, oh, gotta add a mistake, so I removed it. But that takes care of that syntax error, so let's save and try again. And now we get a syntax error on the if, expected unindented block. So we got this this thing, but we expected something indented. And why is that? Because after a while statement, you have to indent. So let's go ahead and indent both of those. Because if I just indented this one, I would get expected unindented block on this one. That's not really a unique error. Let's save and try again. Number is about 2. Unorderable types. Built-in function or method less than int. So I got input. I got input here. Then I'm saying while the user's input is not 3, right? No, this is input the function. So let's say input equals number. We have the number that the user entered, right? How about 2? Unorderable types, string and integer. Because number is a string. How about also notice not just the error, but it asked for a number, and then we said 2, and it printed 2 back at us. We didn't want that, right? The reason it's doing that is because I put the input call inside a print call. So I have a print, and then what is it going to print? The result of this input call. So it calls the input function with a number prompt, and then I enter 2, and then that input function returns the string 2. And then we print it. It's not what we want. What if we want to print multiple things? One in our input prompt, number, and we don't need a space because the default default separator is a space. Number must be integer. Let's save and try it again. It doesn't like that either. Input expects 1 argument. It is not actually the print function. It does not do that. It's not like print that behaves exactly like print, only gets input afterward. You send it 1 argument, and if you want to combine them, you use some form of string concatenation or formatting or something, because it doesn't do that. Input number. Okay. How about num equals input number? Because I want to, I don't know where to go with that one. Num equals input number, while num is less than or equal to 3, if num less than 3, if num more than 3. Okay. Let's see what error we get now. Can you guess? I hope you guessed that one. Of course, in Python 3, the input function does not evaluate anything you enter, so everything is a string. Can you guess what error we'll get now? I'll give you a hint. The same one. The int function does not operate in place. It returns a new value. While num not equal 3. And now what'll happen? 2, very good, too low. So I'm going to go ahead and kill that. We entered the string of 2, and then we converted it to the number 2. 2 is not equal to 3, and then we checked is it less than 3, then it's too low. And then we go back to the top of the loop, it's still 2, and we print too low. So that's an infinite loop, because you don't change the condition within the loop, so it will not end. That's how that works. Let's do the following. Num equals int input number. So I'm kind of streamlining it a bit. Don't need to make the same error multiple times. And now let's do this. Number is, how about 2? That's too low. So that works. Very good. How about 5? Nothing. And 105 is not 5. Doesn't do anything. And now it'll be looping and not doing anything. So I have to kill it. So I entered 5. And 5 is also not 3. And it's not less than 3. So it did nothing. So it just has another infinite loop. So that means we have to do this every time. But we have handling for whether it's greater than 3, don't we? No, we don't, because it is not indented at the correct level. So we do that. We also want to do that in each case, right? Print correct. Okay, what now? Number, how about 2? Too low. 5, that is too high. How about 3? Nothing. So why didn't it print correct? That's because we have the correct inside the loop, which is which will be seen after checking the number. Basically, we get an input right in here, and if the number, this only is executed if the number is not 3. 3, 5, less, greater than, else. I wanted to do something with elif. What could I do to demonstrate that? I don't know if that'll happen. That's okay. Generally, when you want mutually exclusive branches, you need elif. Because without that, it will check whether it's less than 3, and then it will go ahead and check if it's greater than 3. Oh, no. Let's do the following. Let's just run this again with 2, and then how about 3? Correct. So why did it work this time where it didn't work the last time? We didn't get it correct when we entered 3, right? A different behavior, because we got num was less than 3, because we entered 2 first of all. 2 isn't 3, and 2 is less than 3. So it prints too low, and then asks us for another one. And then this if will actually be checked regardless of what num was equal to, because this is not connected to this in any way. This if block and this else are connected. If this condition is satisfied, this block will run. If it is not satisfied, then it looks for this else. But if we got a number that was less than 3, we entered 2, right? And it printed too low, and then it asked for another one. Then we said, how about 3? 3 isn't greater than 3, it's exactly equal to 3. And so it went to the else, because it's not greater than 3, so we print correct. But if we just entered an initial number that was, if we had 2 and then 5, if we entered 5, it would be too high, but it wouldn't be on a separate iteration of this loop. So now only one of these will run each time. We have less than 3, and we have whether it's greater than 3, and this is all the same num, because we're not getting a... This num is the same as this one and this one. This one and this will only be looked at on the next iteration of the loop. So if we have the number is not equal to 3, then we go into this while loop, into this block. We check if it's less and it's more. What else can it be other than less than 3 or greater than 3? It can only be equal to 3 if neither of these is satisfied. But if it was equal to 3, we wouldn't have gone in this in the first place. So we don't need this at all. It will never happen. But it'll eventually happen when they're entering a correct answer, and that's that means we will break out of the loop. So it can just be outside the loop. What else can we do? I think this will actually work in theory. I mean, there's no input validation. If they enter something that can't be converted to an integer, etc., then it won't work. But let's run this. What do we say? 1, that's too low. About 3, correct. Let's try again. 5, too high. 5, too high again. 4, too high. 2, too low. Too low. Correct. That's great. Notice how we're getting input several times. We can slightly streamline that by taking this out of here and making this happen unconditionally, because it'll be either too low or too high. And this doesn't need to be an elif because there's nothing else it could be. So let's make it an else. Else doesn't take a condition. Actually, let's save that and then run it and see what happens. It's invalid syntax because else means any other condition besides this one in the connected if. You can't add a condition. If you want to check a certain specific other condition, you use elif. But we just want everything else. Too low, too high, and do that. We still have 2 input calls. In some languages, there's a construct called do while. Instead of a regular while loop like we have here, other languages have that. But the do while is different in that you have the loop condition after the block of what happens. So basically, you would have something like do stuff while condition with like semicolons and junk everywhere. But the way this works is it sees the compiler sees do, and so it will execute this stuff first once. It'll just go ahead and do that. And then if condition is true, then it will loop back to the beginning over here and execute stuff again. So it's basically a while loop that that executes its contents at least once starting out initially, and then sees whether it has to do it again. Instead of 0 or more times, it's 1 or more times. Python doesn't have that construct. What we do is we have an infinite loop. 1 evaluates to something truthy, so it works. A lot of times you'll see beginners do something like 1 equals 1, and that's true. But other things that are true are 1 or true, a while true loop. That's kind of the name of it, but 1 is shorter. And we will take this out here and we'll put it into there, and then we'll indent that and we'll remove this. We're gonna make that inlined. We're actually going to do elif now because there's no other condition we're checking here. It's 1, it'll always happen. So it might be that we go into this loop and num is equal to 3. So we need elif num is greater than 3. And here's our true condition. And we need to do this and that. Now what else do we want to do? Let's find out. How about 2? That's too low. How about 5? That's too high. How about 3? That's correct. Keep guessing. We still have an infinite loop. It's not iterating as fast as the console output can handle, but because it has an input call on each one, so it's waiting for input. But it is still infinite. It won't end because the condition never changes, and we don't do anything to stop the loop. And to break out of a loop, we use break. So this is the classical Python replacement of a do-while loop, while true, and then a break. And that's basically it. But of course it doesn't have things like, what if we enter a number of potato? Then it doesn't like that. But that's not necessarily a common beginner mistake. That's input validation, and it's a whole other thing. Oftentimes a homework of this type will say the user is going to enter a number. Okay, just assume they're doing that properly. Some more advanced homeworks will say don't assume that. They might not want to. And then you have to check for that. Easy way to do that is num equals int num except. One beginner mistake that's not really a gotcha or not something that will produce errors, like that's a syntax error or whatever. But if you have a bare except, it will catch any problem, not just the one that you were maybe expecting. Like if you have code in a try block that says try import my library, and then library.parse my file.txt, and then except print file not found, right? But you may be expecting an error from library.parse, sorry, my library, and you say, well, maybe this file isn't found. So if it isn't, catch the error and say file not found. What if the user is on a machine that does not have your my library installed? They will get some kind of import error saying my library not found, but it will say, it will catch that exception and say file not found, and they will be like, the file is definitely there, I don't see the problem. It's because you have caught all exceptions, and you're only telling the user about one of them, so don't do that. Sometimes it makes sense if you want to try a whole bunch of things and just say like something didn't work. If you don't want to make a whole bunch of behaviors and error messages, etc., just put it in a bare except and say error. I don't know. I think I have that somewhere, and it can be okay, but generally don't do it. This is a value error. Print must be a number, and continue. If I didn't have this continue in there, it would just keep going, and num would say must be a number, and then it would still give me an error saying we're comparing a string, because this operation failed, so nothing new was assigned to num, so it's still the string from up here. So we say continue, and that will bring us back up to this loop, and we will ask for a number, and then we will get a number, etc. And now what happens if we say potato? Gotta spell potato correctly. Must be a number. How about 3.4? Must be a number. 3.4 isn't an integer. How about Does it work if I do 1e? Does that work? No. That's for floating point. Let's try the following, actually. Let's change this to float. Get a float first. So now, if we enter 4, it's wrong, but if we enter 3 point something, that's correct. It's close enough, because it says 3.8 is a floating point number, and parse that as 3.8. And when you send a floating point number to int, not a string representing a floating point number, but the actual number itself, it just truncates the decimal portion and returns the rest, the integer portion. So you get 3, which is correct. Now let's try a little something. No, must be a number. Oh, because it tried int as well. What if I had done, in theory, we don't necessarily need this. 3.1, it's a little too high. How about 3? Because 3 is equal to 3.0. Then you get into problems with comparing floating point numbers, and it's a big mess. But let's try this. Not a number. Correct. That's a nice way to cheat, isn't it? So what happens is that you can get the string capital N, lowercase a, capital N, and you can send that string to the float function, and you will get the value NaN, not a number. There's also oh, inf is too high. Yeah. Greater or less. So that works. There's also INF for infinity and negative INF for negative infinity, but those are less than, or those are greater than and less than 3, respectively. So they work. But NaN, not a number isn't less than 3. And it isn't greater than 3 because it's not a number. So it goes into else and says correct. Now we could change this to elif number num equal 3. We could do that, but better would be keep this as int, and then you can't mess with it with not a number. I think try, accept, continue, break. It's good practice to put the success block of try, accept in an else. You have try, and this is what you want to run while looking for errors, and accept is what happens if something within the try block produced an error. And if you went through the whole try block, the whole try block and nothing produced an error, you can have something called else. That means we tried everything and it was good. Thanks for the number. Something like that. I don't know. But in this particular case, we have a continue anyway. So if we could get rid of that and indent all this, and then we would just this is perfectly valid as well. Get a number, try to make it an integer. If we can't, print an error message. But if it works, then continue with the program. Doesn't save you any lines because it's else instead of continue. Doesn't really matter. we save on indentation, I guess. We don't necessarily have to have that error message. Try except blocks can also have a finally attached to them. Try except else finally. Try is try this. Except means if something in the try broke, do this. Else is if nothing in the try broke, do this. And finally is run this regardless. And it really does mean regardless. If you have a function def try return 0 except return 1 else return 2 finally return 4. What do you think that'll do? What do you think that will do? Def, guess. Time to guess what it'll do. If you're watching the stream here or watching the archived video, what do you think it's going to return? Try means it will try this, and if there are errors, it will go here. Otherwise, it will go here. I don't know why I wrote 4. And regardless, it will do this. Keep in mind that return leaves the function. So, what do you think we're going to get? 3. Regardless of what else happens, there is no error here. It's going to try that, so it's a 0. That's fine. We'll just return that, and that's no, because there's a finally, and we have to do that. And even if this is no errors here, we'll go into the else, right, and return to no. Because there's a finally, this is what must happen. So there you go. I'm gonna take that out of the thing. That's not necessary. The program is called numberguess.py, and that is what it is. So that is the stream for today. I hope you enjoyed it. I guess I kind of put some non-beginner stuff in there later on, but that's okay. After watching the first 15-20 minutes, you will no longer be a beginner. You are a pro at Python. So yeah, thanks for watching. Tomorrow will be a game of some kind, and day after that, I'm not sure, but leave a comment, and maybe I can do what you suggest. I don't know, we'll see. So remember to like, comment, and subscribe, as always. And I will see you next time. Have a good one.